Hello guys, welcome to my YouTube channel. In today's video we will be looking at the effect of an electric current in a conductor. So we'll be looking at issues like this and this to understand what causes these effects we are seeing here. So for example here, let's look at a heating element here connected to some source of power, and when a switch is turned on we can see that the heating element comes on. So this is what we call heating effect of an electric current. So when current flows through a high resistor wire called electric element found in stoves, in also heaters, in also pressing irons, what happens is that the temperature of the electric element increases, producing heat in the process. The heat produced depends on the following factors. Factor number one, the size of the flowing current. Factor number two, the size of the resistance of the conductor. Then factor number three, the size of the voltage. So the heating effect produced by an electric current is used to 1. Cook food on a stove, then 2. Warm the environment in heaters like this one here, then 3. Heat water in electric kettles or immersion heaters. So this is an electric kettle heating water, and also this is an immersion heater. Press clothes also in electric or pressing irons like here we are seeing here. All right, so you have seen the effect of an electric current. So we have seen that the effect of an electric current can be applied in so many issues in our real life. So let's go to another part here where we are going to look at an electric bulb here connected to some source of power. If the switch is closed, the electric bulb is able to produce some light. So this is what we call the lighting effect of an electric current. Similarly, when an electric current flows through a filament made of tungsten or an element of high resistance, the temperature of the filament increases, producing heat in the process. So like this one, when we switch on, so current passes through this filament here, its temperature increases and it starts producing heat in the process. So we are saying this heat makes the filament to grow white, producing light as a result. So the light produced by the electric current depends on 1. The size of the electric current flowing through it, then 2. The size of the resistance of the conductor, then 3. The size of the voltage. So the light produced is used to provide light in homes and streets, like you can see, homes and streets. All right, so now let's move. Let's look at another situation here where we have a straight wire conductor here and a cell, and a conductor is connected to the cell, positive part of the cell, and also the negative cell part of the cell is connected to this part of the conductor. Then if as it is closed like this, we see some magnetic fields here being produced. This is what we call the magnetic effect of an electric current. All right, so this is what we call the magnetic effect of an electric current when it flows through a conductor. Then around the conductor there will be some magnetic field effect. So what we are saying here, if this is negative, this is positive, then the direction of current is from the negative to the positive. All right, so when an electric current flows through a wire, a magnetic field is produced around the wire. So we are saying the direction of the magnetic fields is determined by the right hand grip, like this right hand grip here, where the thumb here points in the direction of the current, and then these curled fingers here, the curled fingers here points in the direction of magnetic field. So if this points in the direction of current, then these fingers, as they're curled, they're pointing in the direction of the magnetic field lines. So meaning we can mark pointers here to indicate the direction of the magnetic field lines in this situation. All right, so what we can know here is that the magnetic field strength The strength and direction of the magnetic field depends on one, the size and the direction of the electric current, where if the current is increased, the field will get stronger and vice versa. Then, if the direction of the current is changed, the direction of the field will change. All right. So let's look at the diagram which shows a view of magnetic field lines from the top of the paper. So if you are viewing the magnetic fields produced around a wire from top of itself, like this one here. So you are viewing it here. So you can see that the magnetic fields in this way points out of the paper. So we say when current flows out of the paper or the page, this is how we indicate by a small circle with a dot inside. So that small circle and the dot inside indicates the current flowing out of the page. And if current is flowing out of the page, then the direction of magnetic field line is anti-clockwise, like this. Also similarly, if we have this situation here, then it means that the current is going into the page. So if current is going into the page, then the direction of magnetic field lines is clockwise, like this. All right. So what you have to learn from here is that this arrow here actually helps us or guide us. So in this situation, we consider current going out of the page represented by this arrow, this side of the arrow, which is a sharp and pointed, and thence by a dot. And then this behind side of the arrow, the other side of the arrow here, represents the tail of the arrow, and it shows that the current actually is going out from this side going to that way. So the behind side here is represented by a cross here, or X, or a multiplication like that, meaning current is going into the page. And then using the right hand grip, we will be able to know that current or the magnetic field will be actually anti-clockwise.